Hello everyone, welcome back to another video in the LLMs related playlist. In this video, I'm going to show you all how you can train your own function calling LLM, where I'll also cover how you can build a function calling dataset and fine tune on top of it. Now let's start with an explanation of what is function calling in LLMs. Function calling is a concept where if you have an LLM which has a tremendous capability, but to use it to its maximum potential, you can use function calling. For example, if you want to use your LLM to open a notebook, for example, in your system, for example, Notepad, okay, by default it can't. But when you provide a tool for it, it will be able to do that. And that is what happens with function calling. So, for example, if your LLM is here, you will provide it with n number of tools actually. Okay, keep it like this. So let's take 4 for example. For example, this LLM will be able to do able to act as a calculator. Okay, this LLM will have access to your files. Okay, probably access to your calendar, and then access to internet. Okay, all are tools here. Okay, these are all tools. So for example, if I have a use case of opening your own favorite file, okay, let's say you have it as favorite.txt. Since it has access to your files, it will be able to open the favorite.txt by itself by using this files tool. Okay, and if you have some calculations, if the LLM can't directly do it, it can use the calculator. Okay, and then let's say you have some questions and it needs to search over internet, it can use this tool, internet tool. And then if you have some doubts in your calendar, for example, what are the meetings I'm taking today, it directly can't say because it doesn't know what is your time schedule, but when you provide the calendar, it can do. So this is function calling actually. Okay, this always has the power to do a lot of things, but we are aiding it. These tools will aid it to use the power to the maximum potential. That is what will happen with function calling. Okay, usually function calling will be provided with the help of JSON format. The tools will be provided with a JSON format. Okay, and then we'll provide some kind of input, and then it will try to make a function call. Okay, so this is how it happens with function calling in LLM. Okay, now let's see how you can build a function calling LLM dataset, and then we'll move on to how you can fine tune your own LLM with the help of such a dataset. Okay, so now what I'm going to do is I'm going to take the dataset which I used, which is Lilac AI Glaive function calling dataset. Okay, so here we are concerned about this specific column. Okay, for this, what I'm going to do is, here you have your from system and value, these kind of things, right? But when you are building from scratch, this won't be needed. I'll show you the exact format which is needed. Okay, just give me a minute. So here is a sample dataset format. So from we'll start with the system prompt, okay, which will be your function calling tool being provided. So here we'll provide it as follows. Okay, first you will provide your simple system prompt, for example, stating that you are a helpful assistant with access to the following functions or tools, if you want to put that way. And here is the tool whenever it is required, use them. That's what we are saying. Okay. And the name is calculate median. Description you should provide, which is calculate the median of a list of numbers. And then a parameter is required. In the parameters, the type is object always. Okay. And the properties would be numbers, which is a type as array, which means it will have a lot of items in it, and each of the item inside that is number. Okay. And the description is a list of numbers. Okay. So I'll put it this way. So let's say for your function, it is calculate median. If you have a function like this, okay, and it takes array of numbers, and whatever it does inside doesn't matter. So what you need to provide is first the name, okay, and a description of this function. And then what you would need to do is you will provide the parameters next, actually. Okay, parameters, where always the type will be object. Okay, and the properties of the parameters would be, okay, here we have array, right? So it will become array or numbers, whatever you want. For example, numbers. Okay, what is the type of it? It is an array, right? It's not list. Okay, it is in Python, it is list, but usually it is called array. So you'll provide the type as array, and whatever item is there inside that, because array will have list of items, right? 1, 2, 3. Those will be integer. Okay. Along with this, you will also provide a description for the parameter, which is the list of numbers. Okay. So this is how you need to frame a function. For example, another function, browse website. Okay. Web URL, we'll put it that way. So it will become something like name browse URL. When I'm doing this, probably you can also try to write alongside me. Okay, it will be a very good practice for you. And then for description, I'll just keep it as, like browse, something like that, but it will be very detailed. You can understand the point, right? It's just for explanation. And the parameters would be something like type is object. Okay, and then we would have the properties here to be just a URL, right? So it will be URL. Okay, and then here the type would be string, and the description would be the URL to browse. Okay, and that's all. You would have written some logic in here. So if you make a function call with the approximate URL alone, it will be able to do that. So now you can ask, okay, Vasant, this is very simple. Where you can use this? For example, if you are building an agent which will take a question, and based on that it needs to make a search. Okay, so once you find a URL, you need to scrape the URL, right? So for that and all, you can use this browse website. So you will be able to create your own custom tools. Okay, I'll also provide this dataset format for you all to like work around. Okay, but right now what we'll do is we won't have this specific format data, so we'll make a data set to become this format. Okay, I'll show you how I did that. So for this, what you can do is, the nearest data set coming even close to this would be this dataset lilac glaive function calling, right? So whatever format which I showed now is known as chat ML format. Okay, so for this you will also be required to format your dataset into chat ML format, and that is possible with the help of Hugging Face apply chat template method. Okay, so now what I'm gonna do is show you all how you can format this dataset and then fine tune it with the help of Unsloth AI. Okay, so for this I'm gonna use Kaggle kernel. Okay, for fine tuning I'm gonna use Kaggle kernel because I'm bored of Hugging Face, to be honest with you. Sorry, not Hugging Face, Collab. So for a change we shall use Kaggle. I'll put the accelerator to be GPU T4. Okay, and here now we'll start the coding part. So first we would be required to install Unsloth. Okay, so Unsloth is not defaultly available in pip, so we'll be installing it like this. Unsloth collab at git, the source git. Okay, along with that we'll also install transformers trl and 1db. Let's run this. Okay, next we would need to make some imports, and I'm gonna show those now. Okay, these would be the imports which is required from Unsloth. Import fast language model. Oh, what happened? Fast language model, and then we would require trainer. Is it even like this? From TRL import SFT trainer, and then we'll also import training arguments from transformers. And then we would need dataset as well. So for that we'll use load dataset function. And then finally we'll import torch. Okay, all are done now. Let's also run this. Let it keep running. Okay, now first we need to load this dataset. Okay, so what I'm gonna do is I'm just gonna copy this, and then for this what you need to do is just call dataset equal to load underscore dataset, and then have this and provide the split to be train. We need just a training dataset, so for that we'll be providing split as train. Okay, so we can run this also. Then now it is building Unsloth. Okay, Unsloth, if you're wondering, is a library which will enable you to fine tune your models with very much higher speed. So it will be around 2x to 3x speed based on the number of parameters there in the model. Okay, so to now create the dataset, first what you would need to do is first, you should create the tokenizer, and it is required that you can use the tokenizer from Unsloth itself. So for that, what we do is model comma tokenizer. This is how you can create your model and tokenizer by using Unsloth. Okay, we'll be calling the fast language model. uh, it's funny or ironic, like it's fast, and that's why they've provided as it is fast language model. And in this, you would need the following parameters. What is your model name? The model name, we can provide it as Unsloth's Gemma model. Okay, we'll provide Unsloth slash Gemma. Let's fine tune a small model. Okay, it will be like faster for us. Gemma 1.1. There is 1.1 which came into the picture, very latest one. Here it is, 2 billion. Let's use this model. Okay, so here what we can do is we can provide this one here, and then we can also provide the max sequence length to be 512, and then load in 4-bit is true, and then there is d type to be none. Okay, so now the imports are done. Let's run the dataset as well, or load the dataset rather. Okay, and we'll also load the model and tokenizer. Model and tokenizer are being downloaded now. It's high speed. So once the model and tokenizer are done, what we'll do is we'll call the model to become a LoRa model. So for that, what you need to do is call fast language model dot get underscore peft underscore model. Sorry. And here I'll just provide it from here itself, model, and then you need to provide your rank. We'll provide it as 16. The LoRa alpha will also be 16. And then your LoRa dropout, let's provide it as 0 itself here. And then we have the bias is equal to none. These are all very usual, right? And then we would require our target modules. Target modules is provided, and then we require our gradient checkpointing. Use gradient checkpointing. So it will just like checkpoint the gradients whenever there is a save step being enabled. So that is why I use gradient checkpointing, that is set to true. And then we'll set the max sequence length that is required here. Okay, we'll set it as 512. And then here there are some other additional parameters you would require to set, which is use rs LoRa, set it to false, and then also use loft q config. Loft q config use won't be required, and also provide that to be false, because if you are gonna load a model unquantized, and if you wanna get the best output of a quantized model, right, load the model unquantized, use loft q config, provide a loft q config for it, and it will give the best result for you. Okay, now let's run this. It is giving me some errors. Okay, it has said, right, like it has patched 18 QKV layers. Okay, which means we are done with that. The next step is to format the dataset. So for this, what we will do is we'll use the chat templates which is available in Unsloth. From unsloth.chat templates, will use the function get chat template. Okay, in tokenizer we'll apply the get chat template function. Okay, so whenever you call the tokenizer, it will format to this. So for this we require to provide the tokenizer and the format in which you need to apply this chat template. For this we'll use chatml's chat template format. Whatever format I showed you is chatml format. Okay, and for that there is a mapping like this which is required. Okay, I'll show you that now. The mapping is as such that here, not here, where is the data set? Yeah, here it is. There is from in here, right? This from would become your role and the value would become your content. Okay, and whenever there is user, where is the user here? Human, yeah, this human would become your user. So the value of this human, right, it will become like user, and then the user question will be provided, and instead of GPT it will be replaced as assistant, and then the assistant's value will be provided. So it should require dictionary. Okay, and then you can see now, okay, this is the dataset format available, but right now I already said how the dataset format should be, and now you'll see we'll get the dataset in that format itself. Okay, we'll also map the EOS token to true. Okay, now we need a formatting function. So for that I have written a formatting function here. What it will do is it will go through the conversations, because if you see here the column name is conversations. In the conversations it will go through the each of the conversation and it will try to apply the chat template there. Okay, it won't tokenize because we have set here tokenize to false. Make sure that the tokenize is set to false, because the tokenization will happen during the trainer is called. Okay, not here. And map it to a column known as text. Now we'll run this. It will take probably 10 seconds, and in that what we'll do is we'll do a print of the data set of text of 0. Okay, we'll see uh, of 0. We'll see here. Now you can see, right, it is following the same thing which we said there. Okay, whenever there is the tool, first it is provided here. Okay, that is an IM start, and then once it is done you'll do an IM in there, and then another IM start, the user related contents are provided, and then there is an IM in, and then the assistant will start there. So there is an IM start there, and then the function call will be completed, so there is an IM in, and based on the function call the system will try to answer. That is what here it mentions, and the system will say the median is 5. Okay, and then the assistant knows that, okay, now the tool says that the value is median as 5, and then now my job is to say the median of your list of numbers is 5. So this is what is the dataset format is. And now that we have completed the dataset, there are two separate steps for us to do. The first step would be to log into your 1db. So import 1db and 1db.login of your key. Okay, I'm not gonna show the key here, but you can take your key from here actually. 1db. Once you create your account, what you need to do is go to your personal, click user settings, yes, and then click here, there is reveal API key. Okay, you can just click reveal API key and it would ask you to log in. Just log in with your mail ID. Again, if you go there and click API key, it will reveal your API key. Okay, you can just copy that and paste it there. Okay, I'm not going to show that now. So now this login is completed. You can provide your key here. Okay. I'll also provide a Hugging Face login here. So for this, what you can do is go to Hugging Face, click your profile, click whatever profile you have, and settings, click access tokens, and make sure your access token is here and paste it here. Okay. So now this is also done. So now what we'll do is we'll create the trainer. For trainer, I have already written the parameters. So I'll just paste it here. So we are using SFT trainer, in which we'll provide the model, the dataset text field, max sequence length is 512, packing is set to false, dataset num process is 2, which means there will be 2 processes which will do the tokenization. And for other parameters, I think you might all know, max sequence length is 512, which means there will be only 512 tokens. And then the packing is set to false, which means there will be no packing. Packing, what it means is, for example, if you have one data, it is 256, okay, it will try to pack another 256 sequence by adding an EOS token after that, but we are setting it to false. We are also providing the tokenizer and then the training arguments, where we are providing the batch size to be 8, which means for one step it will train 8 samples, and at each steps back propagation will happen. For example, if you want to fasten up your training a bit more, you can try to provide the gradient accumulation steps to 2 or 3 if you're wishing to do that, but 1 is always good actually. Okay. And warm up steps is set to 10, which means for the first 10 steps it will just warm up in the training, which means there will be no back propagation, there will be only forward propagation. Okay, it will just give a basic understanding of the data. And then you have your max steps to be 1000, and then which means there will be only 1000 samples processed. There is a lot of samples here, but there will be only 1000 samples which will be used for training. When you are training the model, make sure that this is commented. Okay. And then the learning rate is 2e minus 5. We are checking if BF16 is supported. If BF16 is supported, we are training it in BF16, or else we are training it in FP16. You can also provide the output directory. I have provided whatever I feel is very good. And optimizer is AdamW 8-bit optimizer, which is an optimizer created especially for quantized model training. The number of training epochs is 1, push to hub is true. We are reporting it to 1 dB. And then here, if you see, the logging steps is 50, which means at every 50 steps, the loss will be like printed there. Okay, let me start the training here, and I'll see you all once the training is completed. Okay. So the training was completed in around 2.5 hours. Okay. So the training loss was also good. It started with 2.5 and ended up with 0.45. That is a pretty good convergence for a 2 billion model, that too in a 2 billion model being probably in 4-bit. It is, I guess it is a pretty good result. Okay. And I'm pushing the model to hub as well. I pushed it. Okay. And the tokenizer was also pushed to the hub. You can provide that here, for which you should provide your username along with the repository directory. Okay. For inference, you can just provide the input string with the tools and the format I said. And I'm expecting the model to say something, but it didn't give good result actually. Okay. So it didn't give great result. For example, here you can see it called the calculate median of numbers, and it said like it is 5 here. But the training was not that much long. If I had done the training for a long time, it would have done a pretty good job. Okay. But soon a very big video is coming up based on this function calling of LLMs. Okay. I'm trying to build a very big project. Probably I'll do that in a member only live. So if you haven't joined the membership, please consider joining the membership, because it helps the channel to grow a lot. So yeah, if you all like this video, if you can like this video, it is free for you, but it does a tremendous good for me. Same for subscribe button. If you haven't hit the subscribe button, please hit the subscribe button and also hit the bell notification, because Whenever I premiere the video, you'll be one of the first people to join that. And finally, share it with your friends and comment your opinions in the comment section. I'll see you all in the next video, guys. Until then, cheers.